This is STA 381. This is Chapter 6, Section 3, Frequency Distributions and Histograms. All right, welcome back. We're skipping Chapter 2, or not Chapter 2, we're skipping Section 2 for now, and we are going right to Section 3, which is about frequency distributions and histograms. So last section, Section 1, remember we looked at some numerical summaries, some basic ones, the mean and standard deviation. Now we're going to look at plotting our data, and in both cases this was quantitative data. So we're looking at plotting quantitative data, we're looking at numerical descriptions of quantitative data. So categorical data has its own set of numerical descriptions and graphical summaries, so just keep that in mind. You need to first make sure your data are quantitative. That's pretty important. Okay, so let's say we have a set of data, and so we see this is actually already summarized for us. We have a set of data and we are interested in making a histogram out of that. So what we would do is really just put it into R or something like that. But we're going to see how this frequency distribution looks. So first of all, we see that the data, it was actually put into what we call bins. So notice the first one says 70 to 90, then 90 to 110, 110 to 130, and so on. Those are what we call bins. So they're basically, they have a certain width to them. Think about it as a bin. You know, it's this bin and we are going to throw all of our observations into it. And notice that the second column says frequency of 2, so 2 items from our data set got thrown into the first bin. The relative frequency is just dividing the 2 by the 80 at the bottom. So if you look at the very bottom, you see that there are 80 items in our data set. 2 divided by 80 is our relative frequency. And then the last column is called a cumulative relative frequency. And that's adding up everything up to and including that bin. So notice the first one says 0.025, but then the second one adds the first to the second. That's where we get the 0.0625 and so on, and that's why you see at the very bottom of that last column, there's actually from 230 to 250 contains all of your data. So this is just, as I said, a frequency distribution. We're just putting the data into a table like this. Now how do we display that graphically? Is through what we call a histogram. So a histogram is just a visual display of our frequency distribution. So we're just taking those bins and the frequencies and just making the height of the bars. And so I'm pretty sure you've seen these like since, you know, years and years ago in high school. But we're not going to construct them by hand. So the book may give you some instructions about how to construct these by hand, but we're not going to do that. So you'll be using R, or you know, if you're just playing with it with some other software. Excel makes it a little bit more challenging. You actually have to do a little bit of work before you can get the histogram, but R is very simple and we'll go through it in at least one of the labs. Just again, noting that terminology, that bin is just that range of the bars, and usually the bins have equal width. So we don't generally construct histograms with unequal width, although I do talk about that near the end of this lecture. It can be a little bit deceptive when you are displaying your data, so we generally just say, hey, generally you want to keep your bins the same width. But knowing how to adjust your bin width is rather important, so that's something, because you don't want too many bars and you don't want too few bars, so you need to kind of play with it a little bit. If you want to Google and see some rules of thumb, you can do that as well. Okay, so here's an example. Compressive strength, and then we notice that we have relative frequency up along the y-axis. So we see that this particular histogram looks fairly symmetric, bell-shaped, rather normal looking. A lot of data doesn't look like this. This is just a really nice data set. And we also want to go back and remember what we learned in the last lecture, which was SOX, which we addressed the shape, the outliers, the center, and the spread. So we look at the shape and say symmetric. We look for outliers. We don't see any unusual data points lying away from the bulk of the data. Those ones at the end, those aren't outliers. Those are part of the distribution. The center seems to be somewhere around 160-ish just by looking, and we can't get an exact number without knowing more information. And then the spread, we can look at the range going from 70 to 250. We can divide that by 6 to get an idea of what your standard deviation is. By the way, just a little quick thing, if we take standard deviation just as a really rough estimate, we can take our range and divide by 6. And why is it 6? Because of the empirical rule that says that 99.7% of your data, if it's bell-shaped, will lie within 3 standard deviations of the mean. So going 3 in each direction would be 6. Okay, so just a real quick mention about histograms with unequal widths. If the data are tightly clustered in some regions and scattered in others, it's visually helpful sometimes. And as I said, this is kind of a rare occurrence. To use a narrow class widths in the clustered regions and use wide class widths in the scattered areas. And in this approach, instead of the rectangle area being the height, it must be proportional to the class frequency. So the rectangle height would be the bin frequency divided by the bin width in this case, to actually help produce something that maybe is not is visually accurate, but it's going to be numerically accurate. So this is just a little introduction to histograms. So let's take another look at a poor one. This one, in this case, there's actually too many bins because we're kind of losing information. So you might think more bins produces more information. Sometimes more bins don't produce more information. So I would probably decrease the number of bins here. The horizontal scale is not at the class boundaries, so it's kind of hard. So that 100 is kind of in the middle and the 150 is kind of in the middle. Generally, we want that scale to hit ends of bars. And the horizontal axis label doesn't include units, so we don't know what strength is in. And you can probably make some guesses, but we don't exactly know what it's in. So producing visually appealing graphs is important, but visually accurate graphs and visually complete graphs is actually equally, or if not more important. A cumulative. Remember we talked about that cumulative distribution a little bit ago. Here's the cumulative frequency plot. So you can see we're accumulating all of the data until we get all of the data included at the very end. But if you only include this plot, you don't get to see what the original distribution is. So if you're going to include this, you really need to include the original distribution, have both a histogram and a cumulative frequency plot, or a cumulative histogram. So let's talk a little bit about shape of frequency distributions. We talk generally about shape in terms of symmetric, which is the one in the middle, skewed either to the right or to the left. So the one on the left is a negative or left skew. The one on the right is a positive or a right skew. So it's whatever direction the actual tail is going off in. So if the tail is going off to the right, it's right skewed. Tail's going off to the left, it's left skewed. Now, one caveat here is don't try to dig too deep into the details of the plot to decide whether it's symmetric or not symmetric. Just look at it as an overall pattern. You don't want to say, well, it's a little skewed here, but then it stops being skewed. You just want an overall idea of the shape. So it's not really important about the details at this point. You're just trying to you're trying to look at the entire forest. You're not trying to look at the leaves or the trees or anything like that. All right, so that gives you an idea of what to talk about, what to look at when you're looking at histograms. Remember SOCs. We have our shape. We have outliers. So going back here real quick, no outliers. We have center, where you can see X bar is there. And the X tilde, just really quick, is the median. So notice that the mean and the median are only really equal when you have symmetric data. We look at our spread and, again, our center. So that's it for this lecture.